All right, so I'm going to do the force and motion lab. Our first experiment is looking at how changing the mass of an object will affect its acceleration. So what we'll be doing, we have this pass car here. I have a metal flag. The initial velocity is starting at 0, so I'm going to start it from rest. I will get the final velocity from this photo gate, which if we measure, each trial is going to start at this is 77 centimeters, and the photo gate's at 27 centimeters. So we're 50 centimeters away, so that's 0.5 meters. So the displacement is 0.5 meters each time. What we'll be doing is we're going to start off with the car. The car itself is 260 grams. On top of that, we're going to be adding these bar masses. So we'll do our first trial with the total mass of the car just being the mass of the car itself, which is 260 grams, which you'll need to convert to kilograms, but there's a little link in the data collection. And then for our second run, we'll add a Pasco cart mass, which is 250 grams. So we'll add 250 grams to that, so 260 plus 250. And then for our third run, we'll add another one. So then we'll have 500 grams on top of the car itself, so 500 grams plus the 260 gram cart itself. We're going to do each run 3 times, so we'll get 3 final velocities. So we can get a good average as to, this is our initial velocity, this is our final. So how much did that final go up in comparison to the other trials? Okay, so the hanging mass we're going to be using for all 3 trials is going to be this 50 gram hanging mass. So we're not going to change the force that's pulling it down, which will be pulling it through this little pulley here. That's what's going to be accelerating the car itself, is this little hanging mass. So we'll keep that the same so that we can see how the mass of the car will affect the acceleration, just the mass of the car. Because if we change this, then we have 2 variables we're changing and we can't see what's affecting the acceleration. Cool. So your hanging mass is 50 grams, so convert that to kilograms. That'll be the same for run 1, 2, and 3. So you want to record that in your data table right over here. The weight of the hanging mass you'll have to calculate. Total mass of the cart, again, we're starting off with a 260 gram cart. We'll have to convert that to kilograms. Then we'll add 250, and then we'll add another 250. The displacement is going to stay the same, again, at 50 centimeters or 0.5 meters. Initial velocity is going to be 0. And then using the LABquest, I'm going to get 3 final velocities for each run. So let's start with run 1. I'll move this over here. Here we go. 3, 2, 1. So our final velocity here is reading 0.959 meters per second. We're now going to do run 2, or run 1, trial 2. All right, 3, 2, 1. For trial 3, we got 0.955. And then for trial 3, we have 0.989. So all around that 0.9 range. Now we're going to do run 2. So now I'm on run 2. I've added a 250 gram bar mass on top. So now we're going to get the final velocity 3 times. For trial 1, we have 0.707. For trial 2, we have 0.744. And then for trial 3, we have 0.751. All right, now we're on run 3. I've now added a second 250 gram bar mass on top. So we're gonna get the final velocity 3 times. For trial 1, we have 0.604. For trial 2, we have 0.588. For trial 3, we have 0.609. For our second experiment, we're going to see how changing the force that's pulling the car is going to affect acceleration. So we're going to keep the car with no masses on it. So it is set 260 grams. What I'll be doing is changing out the hanging mass. So I'm going to start off really small. So I'm going to start with this really tiny 10 gram hanging mass. Then I'm going to do the 20 gram hanging mass. And then for my last one, I'm going to do the 50 gram hanging mass. So the hanging mass will change each time. And so will the weight of it, because the force of gravity will be larger for the larger mass. The displacement of the car is still going to be 50 centimeters, so 0.5 meters. Then we'll have to track the final velocity 3 times for each run. So we're going to start off with run 1. We're going to start with the 10 gram mass. So we're going to get the velocity 3 times. So this is going to be for run 1, trial 1. My final velocity here was 0.422 meters per second. For trial 2, we have 0.447 meters per second. And for trial 3, we have 0.395 meters per second. I'm now going to add the 20 gram hanging mass. All right, this will be trial 1. So that was 0.617 meters per second. This will be trial 2, which I got 0.624 meters per second. And then for trial 3, I got 0.594 meters per second. This is our last run. We're on trial 1, run 3. I've added the 50 gram hanging mass. Our final velocity here was 0.984. This will be trial 2. Final velocity here is 0.970. And then for our third trial, we have 0.988 meters per second. So you have all the data that you need to complete your data table. For your acceleration, you're going to have to calculate that using your initial velocity, your final velocity, which I would take the average of all 3 trials, your displacement, and then you can use one of the kinematic equations to solve for the acceleration in each case.